Auzubillahiminashaitanirrajim. Bismillahirrahmanirrahim. Today we are going to study the 7th standard science, chapter 7, motion, force and work. Introduction. In this lesson we will learn about changes due to motion, distance and displacement, speed and velocity, average velocity and the instantaneous velocity, acceleration and the relation between force, displacement and work. Explanation. We have seen that a change occurs in the motion or the shape of a body with a force X on it. Now let us see how work is done when a force X. Distance and displacement. Distance, displacement. The minimum distance transferred in a particular direction along a straight line is called displacement. Suppose Ranjit's house is at a place A. The figure shows that the distance transferred by the Ranjit to reach his school at B. If we do not take direction into an account, we find that the Ranjit transfers a distance equal to AB plus BC plus CD. However, doing this, his displacement was equal to AD. AD is the minimum distance along a straight line. It is the displacement. Distance. The length of the route actually transferred by a moving body, irrespective of the direction, is called distance. Distance is the scalar quantity. Displacement. The minimum distance transferred by a moving body in one direction from the original point to reach the final point is called displacement. In displacement, both distance and direction are taken into an account. Therefore, displacement is a vector quantity. The unit of measurement of distance and displacement is the meter. In the SI as well as in the MKS system of measurement, velocity is the distance transferred by a body in a specific direction in unit time. The velocity of a body can be calculated by the formula velocity is equal to displacement upon period of time required for the displacement. Speed and velocity. When we see that the speed of a car is 40 km per hour, there is no need to specify the direction. But to predict whether a storm reach a particular place or not, a mention of its direction is essential. The formula for the speed is equal to distance upon time. Let us now use the above formula to find out Ranjit's velocity and speed. When he goes to school, Ranjit's velocity when going from home to school. Total displacement from A to D is equal to 1000 meters. Total time required is equal to 25 minutes. Velocity is equal to displacement upon time. That will be equal to 1000 upon 25 minutes. Therefore, 1000 is equal to 25 into 60 because we are converting here the minutes into seconds. So here 40 meters upon 60 seconds is equal to 4 upon 6 is equal to 2 by 3. That will be equal to 0.66 meter per second. Ranjit's speed while going to school. Total distance is equal to AB plus BC plus CD is equal to 500 plus 700 plus 300 is equal to 1500 meter. Total time is equal to 8 plus 11 plus 6 minutes is equal to 25 minutes. Therefore, speed is equal to displacement upon time. Here, it should be distance. So, here, the 1500 meter upon 25 minutes is equal to 1500 meter upon 25 into 60 is equal to 60 upon 60 meter and the second. So therefore 1 meter upon 1 second. From above calculation, we can understand that the magnitude of his velocity and his speed come out to be different. Average velocity and instantaneous velocity. The velocity of an object can change even while it is moving along a straight line. Suppose that a truck is covering distance of 40 km from A to D in a straight line. Displacement, that is its displacement. If it requires 1 hour for this, its average velocity is equals to 40 km per hour. However, if the truck transfers the 10 km distance AB in 10 minutes, so BC in 20 minutes and CD in 30 minutes, then velocity for the distance AB is equals to 10 km upon 10 minutes is equals to 60 km upon 60 minutes is equals to 60 km per hour. Velocity for the distance BC is equals to 10 km upon 20 minutes is equals to 30 km upon 60 minutes is equals to 60 km per hour. Velocity of the distance CD is equals to 20 km upon 30 minutes is equals to 40 km upon 60 minutes is equals to 40 km per hour. Velocity for the distance AB is equals to 60 km per hour. For the BC it is 30 km per hour, and for CD it is 40 km per hour. The average velocity of the truck is 40 km per hour. So therefore, the velocity at a particular moment of time is called instantaneous velocity. The instantaneous velocity can be different at different time intervals. Acceleration. In the previous example, the truck covered the distance at the velocity 60 km per hour or sometimes 30 km per hour or even 40 km per hour. From the number of seconds required for this change in velocity to take place, the change in velocity per second can be deduced. This is called acceleration. So what is the cause of acceleration? The truck driver increases or decreases the velocity of the truck by means of the accelerator. A toy car that runs on a clockwork spring, when it is released on flat floor, after winding up the spring it goes in a speed. However, when it is hit on one side, it changes direction and keeps going on. If it is collide into a wall, it stops. It happens because that the car comes into contact with something external to it. On a football ground, the direction of the ball moving is in a straight line, but the players change its direction by kicking it. The direction and velocity of the ball changes means on acceleration takes place. The interaction that brings about the acceleration is called force. Force acts on body. Acceleration is a vector quantity. Its unit is meter per second square, that is meter per second square in the symbols. Acceleration is a vector quantity. Its unit is meter second square. Therefore, force and acceleration. To learn about more about the force and acceleration, let's do some experiment. Take a glass marble and let it roll on a big smooth table. After some time, its velocity will decrease and will stop. Conclusion: the velocity of a marble decreases due to the force of friction. Experiment number 2. On a carom board, to the carom coin pushed by a striker will move forward for some time and then it stops. If talcum powder is applied, it will keep moving for a longer time. So conclusion: the velocity of a coin decreases due to the force of friction and the coin stops. If the friction between the carom board and the coin is reduced by talcum powder, the coin keeps moving for a longer time. If no force of friction is acting on a moving body, it will keep moving with a constant speed. The scientist Sir Isaac Newton was the first to study force and the resulting acceleration. Newton's first law of motion. If no force is acting on a body, its velocity does not change. That is, the body does not accelerate. In the other word, if a body is stationary, it will remain stationary. मतलब यहाँ पर क्या बताया है कि अगर कोई भी ऑब्जेक्ट के ऊपर फोर्स नहीं लगाया गया तो वो अपनी वेलोसिटी को चेंज नहीं करेगा या फिर उसके पास एक्सेलरेशन नहीं होगा. अगर वो एक्सेलरेशन नहीं करता है या एक्सेलरेट नहीं करता है, मूव आउट नहीं करता है, तो जाहिर सी बात है वो स्टेशनरी यानी रेस्ट पोजीशन पे है, वो मूव नहीं कर रहा है. If it is in the motion, it will continue moving with the same velocity and in the same direction. और अगर उसके ऊपर फोर्स नहीं लगाई गई है तो इसका मतलब ये है कि वो अपनी मोशन जो है वो कंप्लीट कर रहा है उसी डायरेक्शन में और उसी वेलोसिटी के साथ जिससे वो अपनी मोशन को कर रहा था. Suppose you place a 1 kilogram standard weight on a surface with no friction and pull it with a acceleration of 1 meter per second. The force applied is called 1 Newton. That is 1 Newton. Force is measured by the acceleration that it produces. Force displacement in work. If the figure a string attached to a wooden block on a table is passed over a pulley and tied a block, the block will be seen to move. If the block moves forward, we can see that it has been displaced. Due to the displacement, we say that the force has done some work. So we know that the work depends upon the force and the displacement. The following formula expresses the relationship of work done by the force is equals to force applied to the body into the displacement of the body that takes place in the direction of the force. Therefore, it will be equals to W is equals to 4F into S. Unit work for the joule, force for the Newton, and displacement is meter. In the CGS system, if a force of 1 Newton parallel to the force surface of the table is applied to a wooden block has been and the block is displaced by 1 meter, then it can be said that the force has done 1 joule of work. Summary. A change occurs in the motion or the shape of a body when a force acts on it. The length of the route actually transferred by a moving body irrespective of the direction is called distance. The minimum distance transferred by a moving body reached the final point is called displacement. Velocity is this distance transferred by a body in a specific direction in unit time. The unit of speed or velocity is written as meter per second. The velocity at a particular moment of time is called instantaneous velocity. The change in velocity per second is called acceleration. Acceleration is equals to change in velocity upon time taken for the change in velocity. Newton's first law of motion. If no force is acting on a body, its velocity does not change. That is, the body does not accelerate. Work done by the force is equals to force applied to the body into displacement. Therefore, W is equals to F into S. In the SI system, the unit of work is joule that mentioned by the J and the unit of force is Newton that mentioned by the N. In the CGS system, the unit of work is erg. Here we are ending up our chapter. Before ending up, I want to request you to like the video and subscribe the channel. We will be meet inshallah in the next video with the new chapter and the new concept. Assalamu alaikum, jazakallahu khair.